Now let's get into the fundamentals of quantum. Quantum is a really, really cool subject that basically takes everything think you know and kind of turns it on its head a little bit. All right, quantum mechanics is the study of anything that occurs on the atomic scale. So when we talk quantum, we're talking tiny, um, very small things. Now the word quantum comes from the Latin word, which means to bundle. So basically, quantum mechanics is studying the tiny bundles that surround the nucleus of an atom. Of course, these are your electrons. Quantum studies everything that is atomic and smaller. Now let's talk about the photon. The photon is a quantum of light, it is a bundle of light. It is the smallest bundle of light, photon. Now, when we talk about things being quantized, sometimes the easiest way is let's think about money. 1 cent is a quantum of US money. All right, 1 cent is the smallest amount of money you can have. You can't have anything smaller than a cent in the United States. You can have a peso in Mexico. You can have a different amount of currencies in different countries. But let's talk about the United States. And 1 cent, that's just the smallest. You'll never go to the checkout stand and they'll ask for, $12.57, 0.49. All right. Now, in electromagnetic radiation, light is quantized. So it has tiny bundles called photons. So light is always divided into an integer. That's n equals 1, 2, 3, okay, however many, number of elementary photons. So I can have 5,000 photons, but I can never have a half of a photon. All right, now remember we had the formula C equals F lambda. I'm going to solve this for frequency. So frequency is C over lambda, where C is the speed of light. Now this is true of all electromagnetic waves. All right? All electromagnetic waves follow this formula right here. So as the frequency goes up, the wavelength goes down. But photons have no mass. However, we are going to define, not we, but they define, the energy of a photon is hf, where h is Planck's constant, P-L-A-N-K-S. All right. Planck's constant is either 6.63 times 10 to the negative 34 joule seconds or 4.14 times 10 to the negative 15 eV seconds. You're going to get the constants, just use whichever one is appropriate. Now, the energy of your photon is proportional to the frequency. So as you increase the frequency, the energy goes up. As you decrease the frequency, the energy goes down. So let's look at this. C equals F lambda. C does not change. As I increase the frequency, the wavelength goes down. So high energy means high frequency and small wavelengths. So we have basically two formulas. Here's our third formula. De Broglie discovered that if you take the wavelength and multiply it by the momentum, you always get Planck's constant. Planck's constant was back on the other page. Remember, 6.63 times 10 to the negative 34 joule seconds, where P is the momentum. But momentum is mass times velocity. Now let's think about this. Photons have no mass. But energy and mass are related. That was Einstein's postulate. So if I have the wavelength, I can find the momentum of a particle because that product is just equal to Planck's constant.